Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over part 2 of our Praxis study guide focusing on core mathematics. We're going to be looking at problems 6 to 10. Alright, let's take a look at question 6. It reads, if x is not equal to 0 and y is not equal to 0, which of the following is equivalent to 3 over 2x minus 1 over y? So one thing you want to recollect concerning adding and subtracting fractions is that in order for that operation to be carried out, the denominators of the fractions must be equal to the LCD of all the denominators. Okay? So let's take a look at what we have here. We have 3 over 2x minus 1 over y. Now, if you notice, the denominators are not identical, so we have to convert these two fractions into equivalent fractions where their denominators are equal to the LCD of both denominators. Okay, so the question now is, what is the LCD of 2x and y? We can basically use our LCD chart to determine what the LCD is. So let's go ahead and do that. So what I'll do is I'm just going to list the two numbers I'm looking for the factors of, which is 2x and y. Okay, and I'm going to use my LCD chart here to determine what the LCD is. So the first number can be decomposed into 2 times x. Okay, so what we have here is this is the 2 column, the first one is the 2 column, and this is the x column. When you're creating your LCD chart, all you do is you place the decomposition of the numbers to the right, and then you place them in such a way that only identical factors can be placed underneath each other. Okay, so y is already prime, it cannot be decomposed any further, so I will have to put it here because it's not identical to 2 or x. So if I read it downwards, I have 2 times x times y, which is 2xy. That's the LCD of 2x and y. Okay, so the LCD of 2x and y is 2xy. So what I'm going to do now is my goal is to make these two denominators equal to 2xy. So whatever I multiply the denominator by, I have to multiply the numerator by the exact same factor so that I do not alter the problem. 2x needs a y, so I times it by y on the top and bottom. 1 over y, the y needs 2x, so I times it by 2x top and bottom. Okay, and then let's go ahead and expand it. In the numerator, we have, for the first fraction, we have 3y over 2xy minus 2x over 2xy. So this difference of fractions we have is exactly equal to these. These are equivalent fractions where the denominators are both equal to the LCD 2xy. So now that the denominators are the same, all you do is you subtract the numerator and keep the denominator. Alright? So our final answer is going to be 3y minus 2x divided by the LCD 2xy. Answer to number 6 is option letter C. Alright, let's take a look at question 7. It reads, the number of absences in Mrs. Klein's class for each of the first 3 months of the year is 16, 12, and 17 respectively. If the average or arithmetic mean number of absences for the first 4 months of the year is 14, how many absences were there in the 4th month? Okay, so let's get started by writing down the formula for computing the average of a set of numbers. So the formula for average is as follows. The average is basically the sum of terms that divided by the number of terms that you added. Okay, so sum of terms divided by number of terms. Alright, so let's go ahead and get started with our calculation using this formula. Um, so it says how many absences were there in the fourth month. So we don't know what that is. So let's assign a variable to that, okay? So let um, the fourth absence number be x. Okay, so let the fourth absences the number be x. Okay. What's the given average here? The average of um, all four numbers. It says the number of absences for the first 4 months of the year. First 4 months of the year is 14. So average is going to be 14. Now we're looking at four terms here. Now what's the sum of the four terms that we have that has an average of 14? So the sum of the four terms, starting from 1, 2, 3, including the fourth one, is going to be 16, the first one, plus 12, the second, plus 17, the third, plus x. Okay? We're evaluating this expression because if you look at the average formula, you need the average sum of terms and number of terms to set up an equation. Alright? So if I simplify this, 16 plus 12 plus 17, add it all together, you get 45 plus x. Now the last component of our average equation is the number of terms. So how many terms are we adding here? Number of terms, we're looking for 4 months, right? So we're going to have 4 as the number of terms that we're adding. Now let's recollect our formula again. Average is sum of terms divided by the number of terms. Alright, so this average is 14. We have that right here. Equals sum of terms is 45 plus x. Sum of terms here. These 3 plus the fourth one, which we called x, divided by the number of terms, which is 4. Alright, so we have a resulting algebraic equation. Now how do we solve this equation? To solve this equation involves isolating x. To accomplish that, we have to get rid of the 4 in the denominator and then the 45. We get rid of the 4 by multiplying both sides by 4, and then we just subtract 45 from both sides, and that will be our final answer. Alright, so let's go ahead and do that. Multiply both sides by 4. This divides out. 14 times 4 is 40 plus 16, which is 56. 56 equals 45 plus x. And then to get x isolated, we simply subtract 45 from both sides of our equation, and we get our final answer. X equals 56 minus 45 is 11. The answer to question number 7 is option letter C. Alright, let's take a look at question 8. It reads, at a computer store on Monday last week, the price of a computer was X dollars. On Tuesday, the price of the computer was reduced by 25% of Monday's price. On Wednesday, the price of the computer was further reduced by 40% of Tuesday's price. Question: which of the following expressions represents the price in dollars of the computer on Wednesday? So let's start off by writing, we want to recollect something concerning multiplication. You want to remember that multiplication commutes. That's the commutative property of multiplication. What that basically means is that the order of multiplication doesn't matter. So for example, 2 times 3 is 6. If you reverse the order of this factor is being multiplied, 3 times 2 is 6. So a times b is b times a multiplication commutes. All right, so we're going to be using that towards the end. So to get us started, we're going to write down the formula to compute the selling price when you're given a discount. Okay, so formula for the equation involving selling price and percent off. Alright, so what does that look like? We have the selling price is basically 1 minus the percent off divided by 100. We're dividing this by 100 because we want to convert it to decimal form. Okay, so 1 by minus percent off basically is a percentage that you're actually left with out of 100, and you multiply that by the original price. Okay, so that this computation gives you exactly the selling price after a specific percent off. Alright, so in this particular situation, the original price was the price of the computer on Monday. So let's write that down. The original price is X, so our resulting answer will be an algebraic expression. In this particular case, we have 2% discounts, one on Tuesday and one on Wednesday. Okay, so let's just put them in order. So first percent off, which is the one on Tuesday, is 25%. Okay, what is 25% in decimal form? Just simply write 25 over 100. When you divide 25 by 100, you just simply move the decimal point to the left 2 places, and you have 0.25. Okay. Second percent off is the discount on Tuesday, which was 40%. 40%, let's write that in decimal form. 40 over 100, move the decimal point to the left 2 places, you have 0.4. Alright, so what's the selling price in this particular case? Well, the formula I gave you involves just 1% discount. This problem has 2. Okay? So let's extend the formula a little bit. So in this particular case, our selling price is going to be the first percent discount, which is 1 minus percent off over 100, the first one. And then guess what? We have another 1 minus percent off over 100. And then that will multiply by the original price. Okay, so the first percent off over 100 is the first discount. That's the Monday discount. So this is the first discount. We have another discount on, well, this is a Tuesday discount. And then Wednesday discount, we have another percent. So this is the second discount. Alright, so let's put them all together. Our selling price is going to be the first discount. So the first discount, which is 1 minus percent off over 100. So 1 minus percent off over 100 is 25 over 100, which is 0.25. The second discount is 1 minus the second percent off over 100, which is 40 over 100, which is 0.4. That multiplied by the original price of X. Now if you do your subtraction, 1 minus 0.25 is 0.75, and then 1 minus 0.4 is 0.6 multiplied by X. Now since multiplication commutes, we can reverse the order of our product here, so it's consistent with one of the options we have here. You can rewrite this as 0.6 times 0.75x. Alright, the answer to question number 8 is option letter E. Alright, let's take a look at question 9. It reads, if f is 4x plus if 4x equals 14 plus 9y and y is 2, what is the value of x? So we're given an equation. We're asked to fix the value of one variable and compute the resulting value of the other. Okay, so set y equal to the value of 2. So that will be substituted into the original equation. So we have 4x equals 14 plus 9 times 2. And then we're just going to simply isolate x to get the value of x. Alright, so let's simplify first. We have 4x equals 14 plus 9 times 2, which is 18. The goal here is to get x by itself. We just simply combine these two and then divide by 4. So we have 4x equals 14 plus 18, is 32. Divide both sides by 4. And our final answer, x, is 32 over 4, which is 8. Answer to question 9 is option letter E. Alright, let's take a look at question 10. It reads, in the xy plane above, rectangle RSTW is to be reflected across the y-axis. Question, what are the coordinates of the point T after reflection? So basically, where does this point T right here end up after you reflect it about the y-axis? That's the question, okay? There are two ways you can solve reflection problems. One of them involves the algebraic approach, and the second can be is the geometric approach. We're going to be using both methods in this problem, and on the test you can pick whichever one you prefer. Okay. All right. Let's start off with method 1. Method 1 is the algebraic approach. In order to use the algebraic approach, you need to remember the formula for reflection of the impact of reflection on coordinates. All right. So formula for reflection across across the y-axis. The formula is as follows. So r, the reflection across the y-axis of, let's say, an original point A with coordinates x, y is going to be, so A is the original point, and then the image on the reflection, let's call that A prime, is going to be negative x comma y. Alright, let's study this equation for a second. What this formula is telling us is that when you reflect a point across the y-axis, the other axis, namely the x-axis, attains an opposite sign. Okay? So let's go ahead and apply this formula to point T. So if we reflect across the y-axis point T, which has coordinates 4, 5, guess what happens? The x coordinate attains an opposite sign. So instead of 4, 5 is going to be the opposite of 4, which is negative 4, comma 5. And point T prime will be the image on the reflection. Point T is going to end up on negative 4, comma 5. And option letter C is the answer to this question. Alright, let's do this geometrically. Okay, method 2. You can just do it using the grid that's provided. This is the geometric approach for reflection. So if you're reflecting across the x-axis, across the y-axis, sorry, what does that mean? To reflect across the um, the y-axis. So what you're going to be doing is you're going to be manipulating the y-coordinates. Okay, so you count an equivalent number of units from the y-axis to the point in the opposite direction. So what does opposite direction mean? If your point is located to the left, guess what? You're going to go to the right. If your point is located to the right, you're going to go to the left. All right? So let's go ahead and see what that looks like in this problem. We're reflecting only one point, so we just focus our energy on that. So this is my coordinate system right here. And then we're going to proceed to graph point T, the original point. Point T is 4, 5. 1, 2, 3, 4. That's 4. 1, 2, 3, 4, 5. That's 5 right there. Okay, so this is point T, 4, 5. So if we want to reflect this point across the y-axis, we're going to count the number of units from the y-axis to this point in the opposite direction. Okay, so if you count from the y-axis to this point, how many units is it? So from the y-axis to this point is 4 units. It's 4 units to the right. Alright, so to get to the original, you're going to go 4 units to the right. That's the perpendicular distance of the point from the y-axis. Okay, now if you want to reflect, you're going to do the opposite. Since you went 4 units to the right, you're going to go 4 units in the opposite direction, which is to the left. So you're going to go 1, 2, 3, 4. 4 units to the left tells you where the point is going to be when you reflect it across the y-axis. So this coordinate right here is my reflected point T prime. Okay, so it's going to be 1, 2, 3, 4. Negative 4 right here. So T prime is going to be negative 4, 5. So you can see the visual reflection of the initial computation that we did. When you're reflecting across the y-axis, you do not travel vertically. Your movement is only horizontal, so only the x coordinate is impacted by a horizontal reflection across the y-axis. So we can see that our answer geometrically, which involved reflecting 4 units left, gives us the exact answer that we got before, which is option letter C. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Praxis Mathematics Core exam, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions or comments about what we covered in this presentation or on any math concepts on the Praxis Math Core exam, just place it in the comment section below and we'll be more than glad to support you. More clips and support resources can be found on math.serve.com. Go ahead and check it out. Thanks again for watching and have a wonderful day. Goodbye.